In this video we are going to see the combinatorial proof of Pascal's identity. Combinatorial proof of Pascal's identity. What is Pascal's identity? We all know NCR is equal to n minus 1 CR minus 1 plus n minus 1 CR. So to prove this using combinatorial argument, we will create two sides of the story. We will create two stories, story 1 for this and story 2 for this. And we will show that story 1 is same as story 2. So first let's create story 1, which is pretty simple. Let me write with a different color. Story 1. So what can be story 1? Since it is NCR, means select R elements from n, R distinct elements from n distinct elements, which is definition of NCR. So we will select, suppose we have n length bit string. What is bit string? In a bit string, every letter is either 0 or 1. So we have a n length bit string and we want to create a bit string, n length bit string, which have r number of set bits. What is a set bit? Which is set bit means 1. So there will be r number of ones and n minus r number of zeros. So number of ways to do this is NCR. So story 1 is complete, which is very easy. Now we have to create story 2. Story 2. So story 2 must be related to story 1. We cannot create a different story because they will not correlate. So what could be the story 1, story 2? For story 2, take this same case. We have n length bit string, same, but here we will fix the first position to a set bit. It means 1. First bit is reserved for 1. And another case, this will be n length, but in this situation the first bit will be reserved for 0, and this case 1, this is the first case, this is second case. Case 1 and case 2 are mutually exclusive, means they are not overlapping. You cannot have a string which is present in this case and this case also. This is not possible because they are both same length, and the first is starting with 0 and the second is starting with 1. They are mutually exclusive. Case 1 and case 2 are mutually exclusive. Since they are mutually exclusive, we can add them later, we will see. So okay, so we have one bit set. So how many we want, so that this n length bit strings become this n length bit string have r number of ones, we need another r minus 1 set bits, so that this whole string have r number of set bits. So we have to select r minus 1 set bits from what is the new length here, n minus 1, and number of ways to do this. Number of ways to do this is saying very simple. From n minus 1 c, n minus 1 positions, we have to select this r minus 1 set bits. Okay, this is done. Coming to case 2, here we have n minus 1 available positions, we still don't have any set bits, so we have to select r set bits from what is the positions we have n minus 1 positions. Number of ways to do this is, from n minus 1 positions we have to select r bits. Okay, and we have this plus sign, and we are not subtracting any common cases, means there are no cases that are present in this and this, means these two, case 1 and case 2, are disjoint, therefore we are not subtracting anything, no intersections. Like if they were not mutually exclusive, then we would have to exclude case 1 intersection case 2, we would have to do this if they were not mutually exclusive. Since they are disjoint, this is 5, means this is 0. Okay, we can simply write this a minus 1 cr minus 1 plus minus 1 cr, which was this. Yes, the story 1 was, this was story 1, this was story 2. Story 2 was same as story 1, but it was divided into parts. Okay, so this was the complete proof of combinatorial proof of Pascal's identity.